In 1949, a German mason stood in the rubble of post-war Europe with nothing but a welding torch and a radical idea: build a crane that could assemble itself. Engineers said it was impossible, a machine that could lift itself into the sky, piece by piece, without external help. But Hans Liebherr wasn't just trying to rebuild Germany's shattered cities. He was about to create the tower crane, a machine so revolutionary it would construct every skyscraper, bridge, and mega project for the next 75 years. But first, he'd face a catastrophic prototype collapse that nearly killed 3 workers, a patent war that threatened to destroy him, and a business decision that would either make him a legend or bankrupt his family forever. From that single welding shop in Kirchdorf, his cranes would rise on 6 continents, lifting the Burj Khalifa, the Sydney Opera House, and nuclear reactors in the Arctic. This isn't just about cranes. It's about how one man's obsession with a self-climbing machine transformed construction forever and built the modern world, one impossible lift at a time. A construction foreman stood on a Berlin street in 1949, staring up at a half-demolished building. His crew needed to lift steel beams to the 4th floor, but their mobile crane couldn't reach high enough. They'd have to build scaffolding, winch materials by hand, then dismantle everything and move to the next site. It would take weeks. Across Germany, the same scene repeated daily. Cities in ruins, desperate need for housing, but construction moving at a medieval pace. This was the world that Hans Liebherr walked into when he returned to his small Bavarian village of Kirchdorf an der Iller. At 39 years old, he'd spent years as a construction contractor and mason. But the war had destroyed everything. Germany needed to rebuild fast, yet the tools hadn't evolved since the 1920s. Mobile cranes were too short. Static cranes required massive foundations and couldn't grow taller as buildings rose. Engineers were stuck using the same logic that had failed for decades. Liebherr saw the problem differently. What if a crane could build itself taller? What if, instead of needing external lifts or massive ground support, a crane could climb its own tower, adding sections from the inside as the building grew? It sounded absurd. Cranes were meant to lift things, not themselves. The physics seemed impossible. How could a machine support its own weight while simultaneously hoisting itself upward? But Liebherr had watched masons work. They'd build a wall, stand on top of it, then build higher. Why couldn't a crane do the same? In his small workshop, little more than a shed with a welding torch and basic metalworking tools, he began sketching designs. His neighbors thought he'd lost his mind. Hans is building a crane that walks up buildings, they'd joke. Even his own family questioned whether post-war scarcity had driven him to fantasy. The first prototype took 9 months. Liebherr used salvaged steel from bombed factories, welding together a framework that looked more like a radio tower than construction equipment. The core innovation was deceptively simple: a hydraulic climbing system inside the tower. The crane would lift a new tower section, insert it beneath itself, then use hydraulic jacks to push the entire upper structure, cab, jib, and all, upward. Once elevated, it would lock into place and repeat the process. On paper, it worked. In reality, nobody knew if the tower could handle the stress, if the hydraulics would fail under load, or if the whole thing would simply topple over. Liebherr's first test came in 1950 at a small construction site in Kirchdorf. Workers gathered nervously as the crane lifted its first section. The hydraulics groaned. The tower swayed slightly. Then, slowly, the entire upper assembly rose 3 meters into the air and locked into place. It worked, but barely. The crane could only lift 500 kilograms, pathetically weak compared to mobile cranes moving several tons. Worse, it took nearly an hour to climb one section, making it impractical for real construction sites. Engineers from Munich visited and dismissed it as a clever toy with no commercial value. Traditional crane manufacturers laughed. Why reinvent something that already worked? Liebherr knew they were wrong. The potential was obvious to him, even if others couldn't see it. This wasn't about lifting capacity yet. It was about height and flexibility. A crane that could grow with a building would eliminate the constant repositioning mobile cranes required. Once perfected, it would save weeks on every project. He just needed to prove it before his money ran out. And he needed to do it before someone else figured out what he'd discovered. Because if this worked, it wouldn't just change construction in Germany, it would change how humanity built everything. The breakthrough came in 1952, when Liebherr secured his first real contract, a 5-story apartment building in Biberach. The developer was desperate, behind schedule, and willing to try anything. Liebherr showed up with his improved TK-10 model, a spindly tower that looked fragile compared to the massive mobile cranes parked nearby. Workers nicknamed it Der Zahnstocher, the toothpick. But this toothpick could do something no other machine could. As the building rose floor by floor, the TK-10 climbed with it. No repositioning, no waiting for mobile cranes to arrive and set up. The cab operator simply lifted a new 3-meter tower section, inserted it into the climbing frame, and hydraulic rams pushed the entire superstructure upward in 15 minutes. By the 3rd floor, competing contractors were showing up just to watch. The TK-10 could lift 1,000 kilograms to heights of 30 meters. Modest numbers, but the real revolution was operational. That Biberach project finished 3 weeks ahead of schedule. Word spread fast. Within months, Liebherr had orders from Stuttgart, Frankfurt, and Hamburg. Germany's reconstruction boom was accelerating, and suddenly every major contractor wanted a self-climbing crane. Then came the setback. In March 1954, a TK-10 collapsed in Mannheim. The tower buckled during a climb sequence, sending the jib crashing down onto scaffolding where 3 workers stood. They survived, barely. But the incident made national news. Liebherr's climbing crane nearly kills construction crew, read the headlines. Competitors seized the moment, calling tower cranes dangerously experimental and demanding government safety investigations. Liebherr could have folded. Insurance costs spiked. Orders dried up overnight. But instead of retreating, he did something radical. He published the failure analysis himself. The problem wasn't the climbing system. It was operator error combined with a design flaw in the tower's locking mechanism. Liebherr recalled every TK-10, retrofitted them with redundant safety locks at his own expense, and implemented mandatory operator training. This transparency earned him something money couldn't buy: trust. When the improved K-10A returned to job sites 6 months later, contractors noticed the difference. The new model featured a mechanical safety brake that engaged automatically during climbs, preventing tower separation even if hydraulics failed. Liebherr also added load monitoring systems that warned operators before approaching weight limits. By 1956, Liebherr had sold over 100 tower cranes across West Germany. The company moved from that cramped Kirchdorf workshop into a proper factory in Biberach, employing 200 workers. But Liebherr wasn't satisfied with dominating Germany. He saw the entire European reconstruction as his market. The problem was competition. French manufacturer Potain had been watching Liebherr's success and developed their own tower crane by 1957. In Italy, Commodore launched a similar design. These weren't copies. Each company claimed independent invention. But the patent battles began immediately. Liebherr filed lawsuits in France and Italy, arguing his 1950 prototype established priority. The legal war would drag on for years, but Liebherr had an advantage his competitors didn't. He'd been refining tower crane engineering for nearly a decade. His 1958 TK-35 model featured a slewing mechanism that allowed the jib to rotate 360 degrees while lifting, a seemingly simple feature that required completely redesigning the tower's internal structure to handle torsional stress. That innovation made the TK-35 faster and more versatile than any competing crane. A single operator could service an entire construction site without repositioning the tower. Jobs that once required multiple cranes now needed just one Liebherr. The construction world was starting to understand what Hans Liebherr had known all along. Tower cranes weren't just another tool, they were the future, and he was just getting started. By 1958, Liebherr faced a strategic crossroads. Tower cranes had made him successful in Europe, but the market was saturating. Every major German contractor owned at least one Liebherr crane, and Potain was eating into French market share despite ongoing patent disputes. Hans Liebherr made a decision that shocked his engineers. Instead of fighting harder in tower cranes, he'd diversify into machines nobody expected. The pivot began with construction equipment. Liebherr noticed that crawler excavators, the workhorses of earth-moving, were almost entirely American-designed. Caterpillar and Bucyrus-Erie dominated with massive diesel-guzzling machines built for open-pit mining. But European construction sites were different. Tighter spaces, narrower streets, stricter noise regulations. Liebherr saw an opening. In 1961, Liebherr unveiled the L300 hydraulic excavator at the Bauma trade show in Munich. While competitors still use cable-operated systems with mechanical clutches, Liebherr's machine ran entirely on hydraulics. The operator controlled the boom, stick, and bucket through joysticks with precision impossible in cable systems. The 20-ton machine could dig a foundation trench within centimeters of specified depth, then swing 180 degrees to dump spoil into a waiting truck, all in under 30 seconds. American manufacturers dismissed it as over-engineered European nonsense, but contractors loved it. The L300's hydraulic system meant fewer moving parts, less maintenance, and operators who could be trained in days rather than weeks. Within 3 years, Liebherr excavators were outselling established European brands like O and K and Demag. The success funded Liebherr's most ambitious expansion yet: mobile cranes. This was enemy territory. Krupp, Demag, and American giant Grove had decades of dominance. But Liebherr identified their weakness: mobility versus capacity. Large mobile cranes required massive counterweights and hours of setup. Smaller cranes were quick but weak. Liebherr's 1964 LTM 1030 all-terrain crane changed the equation. Mounted on a 3-axle Mercedes truck chassis, it could drive highway speeds to a job site, then lift 30 tons without outriggers for quick jobs, or extend hydraulic stabilizers for 50-ton lifts. The telescoping boom, 5 nested sections extending from 9 to 30 meters, used a revolutionary single-cylinder hydraulic system instead of the complex cable and pulley arrangements competitors used. This wasn't just incrementally better, it was a different philosophy. One Stuttgart contractor reported using an LTM 1030 for 11 different jobs in a single day, setting air conditioning units, lifting steel beams, moving generators, and even recovering a truck that had slid off an embankment. "It's like having 5 cranes in one," he told industry magazines. But the real masterstroke came in 1966 when Liebherr opened his first factory outside Germany, in Killarney, Ireland. The decision baffled analysts. Ireland had virtually no construction equipment industry and a tiny domestic market, but Liebherr understood what others missed. Ireland offered English-speaking workers, low corporate taxes, and easy access to Britain and North America. The Killarney plant produced mobile cranes for export, undercutting British manufacturers while avoiding their labor disputes. By 1968, Liebherr cranes were working sites in London, Glasgow, and Dublin. Orders came from Canada and Australia. The company that started with a self-climbing crane in a Bavarian village now operated factories in Germany, Ireland, and France, with licensing deals in Switzerland and Austria. Hans Liebherr's empire employed over 3,000 workers building tower cranes, mobile cranes, excavators, and even concrete mixers. The toothpick crane that Biberach workers had mocked 15 years earlier had become a global industrial force. But Liebherr's ambitions went far beyond construction equipment. He was about to enter the most competitive, unforgiving market in heavy machinery and take on the American giants directly. In 1968, Hans Liebherr visited an iron ore mine in northern Sweden. Standing at the edge of a massive open pit, he watched American-made Bucyrus-Erie shovels, each weighing 500 tons, load ore into dump trucks. These were the giants of mining, machines so large they required on-site assembly and generated enough power to run a small town. Bucyrus-Erie, Marion, and Caterpillar had dominated mining equipment for 50 years. No European manufacturer had ever successfully challenged them. Liebherr decided he would be the first. His engineers thought he'd lost his mind. Mining equipment operated on a completely different scale than construction machinery. A tower crane lifting 5 tons was impressive. A mining shovel moved 50 tons per scoop, all day, every day, in conditions that destroyed lesser machines. The capital investment alone was staggering. Developing a mining excavator would cost millions with no guarantee of success. But Liebherr saw what others didn't. The Americans were building dinosaurs. Their machines were powerful but inflexible, designed for massive American coal mines and copper pits. European and developing world mines were smaller, required mobility, and couldn't afford year-long delivery times. There was a gap in the market for something between small construction excavators and American super shovels. The result was the 1970 Liebherr R991, a 100-ton hydraulic mining excavator that redefined the category. Unlike cable-operated mining shovels that required 3 operators and constant mechanical adjustment, the R991 ran on a fully hydraulic system controlled by one person. Its 6-cubic-meter bucket could load a 50-ton haul truck in 4 passes, and the entire machine could be disassembled, transported, and reassembled at a new mine in 2 weeks. Impossible with American equipment. The real innovation was the crowd force, the digging power of the hydraulic cylinders pushing the bucket into material. Liebherr's engineers developed a hydraulic system generating 450 kilonewtons of crowd force, enough to rip through blasted rock without pre-loosening. Caterpillar's comparable model needed 30% more fuel to match that performance. Swedish mining company LKAB bought the first unit for their Kiruna iron ore mine. Within 6 months, they ordered 3 more. The R991 worked in temperatures dropping to minus 40 degrees Celsius, conditions that froze hydraulic lines on competing machines. Liebherr had designed cold weather seals and used synthetic fluids that remained viscous in Arctic conditions. Knowledge gained from operating construction cranes in Scandinavian winters. Then came the American expansion. In 1972, Liebherr opened a manufacturing facility in Newport News, Virginia. A bold move directly into Caterpillar and Bucyrus-Erie territory. The factory would build mining trucks, massive vehicles designed to haul 150 tons of ore from pit floors to processing plants. The T282, unveiled in 1974, featured a diesel-electric drive system. A 2,700 horsepower diesel engine drove electrical generators, powering electric motors at each rear wheel. This wasn't new technology. Locomotives had used diesel-electric systems for decades, but applying it to haul trucks was revolutionary. Electric motors delivered instant torque, giving loaded trucks better acceleration and hill climbing ability than purely mechanical drivetrains. Operators reported fuel savings of 15 to 20% compared to mechanical trucks, and maintenance costs dropped because there was no massive transmission to service. American mining companies were skeptical at first. Caterpillar had been building mining trucks since the 1960s, and buying from an upstart German manufacturer seemed risky. But Phelps Dodge Copper Mine in Arizona took a chance on 3 T282 trucks in 1976. After 1 year of operation, those trucks had averaged 92% uptime, significantly better than the industry standard of 85%. Word spread quickly through America's mining belt. By 1978, Liebherr mining equipment operated in Canada's tar sands, Chilean copper mines, and Australian coal fields. The company that started with a self-climbing crane now built some of the largest mobile machines on Earth. But success came at a cost Hans Liebherr would never see. On October 28, 1978, Hans Liebherr died suddenly of a heart attack at age 68. He'd spent the morning at the Biberach factory inspecting a new tower crane prototype, then collapsed in his office. The man who'd built a global empire from a village welding shop was gone, leaving behind a company with 12,000 employees and factories on 3 continents, but no clear succession plan. The crisis was immediate. Hans had structured Liebherr as a family business with complex ownership split among his children and relatives. Within weeks, competing visions emerged. Some family members wanted to sell divisions to European conglomerates offering premium prices. Others pushed for aggressive expansion into new markets. Without Hans's decisive leadership, the company risked fragmenting into smaller competitors fighting each other. The solution came from an unexpected source: Hans's son, Willy Liebherr, who'd been managing the crane division. At 34, Willy was young for such responsibility, but he'd inherited his father's engineering mindset. In a tense 1979 family meeting, he proposed a radical restructuring: transform Liebherr from a single entity into a holding company with autonomous divisions. Each product line, tower cranes, mobile cranes, mining equipment, concrete technology, would operate independently with dedicated management, but share R&D resources and the Liebherr brand. The family agreed, and the reorganization stabilized what could have been a catastrophic collapse. But Willy faced challenges his father never had. By 1980, the global construction boom was ending. Interest rates hit 15%, crushing equipment sales. Japanese manufacturers like Komatsu and Hitachi were flooding European markets with reliable, cheaper excavators. And Caterpillar, finally recognizing Liebherr as a threat, launched aggressive pricing campaigns to reclaim mining market share. Willy's response was counterintuitive. Instead of cutting costs, Liebherr doubled down on innovation. The 1981 LTM 1400 mobile crane exemplified this philosophy. With a 400-ton lifting capacity and an 8-axle carrier, it was the world's most powerful mobile crane. But capacity wasn't the breakthrough. The computerized load moment limiting system was. Sensors throughout the crane fed data to an onboard computer that calculated safe lifting parameters in real time, preventing dangerous overloads. Operators could work faster and safer, reducing insurance costs that offset the crane's premium price. The mining division followed similar logic. The 1985 R996 mining excavator weighed 676 tons and featured a 36 cubic meter bucket, nearly 6 times larger than the original R991. But size alone didn't justify its existence. Operational efficiency did. The R996 could load a 400-ton haul truck in less than 5 minutes, and its hydraulic system used pressure-compensated pumps that adjusted flow rates based on load resistance, cutting fuel consumption by 18% compared to fixed displacement systems. These weren't just incremental improvements. They were engineering showcases that reinforced Liebherr's premium positioning. When Komatsu undercut prices by 20%, Liebherr competed on total cost of ownership. Their machines cost more up front, but delivered better fuel economy, longer service intervals, and higher resale values. The strategy worked, but required patience. Between 1980 and 1985, profits were flat. Shareholders grew restless. Some family members questioned whether Willy's expensive innovations would ever pay off. Then, in 1986, the North Sea oil boom created massive demand for offshore construction cranes. Liebherr's heavy-lift crawler cranes, machines that could lift 1,000 tons while maintaining stability on floating platforms, became essential for installing offshore drilling platforms. One crane, the LR1750, set a record by lifting a 750-ton platform module in the Norwegian sector. Video footage of the lift, showing the massive yellow boom straining as hydraulic cables pulled taut, became legendary in construction circles. Liebherr doesn't just build cranes, one engineer commented, they build the cranes that build everything else. By 1990, the gamble had paid off. Liebherr's revenue exceeded 3 billion Deutsche Marks, with operations in 23 countries. In 1993, engineers in Dubai faced an impossible challenge: how to build the world's first 7-star hotel on an artificial island 280 meters offshore. The Burj Al Arab would rise 321 meters, requiring foundation work in unstable seabed conditions, and concrete pours at heights where wind speeds exceeded safe limits for conventional equipment. Every major construction firm said it couldn't be done with existing technology. Liebherr's response was the 710 HC Tower crane, a machine specifically engineered for extreme conditions. Its tower could withstand wind speeds of 145 kilometers per hour while under load, 40% higher than standard cranes. The climbing system featured a double telescoping mechanism, allowing it to rise inside the building's elevator shaft, eliminating the need for external tower supports that would interfere with the hotel's curved sail-shaped architecture. Over 4 years, two 710 HC cranes lifted 28,000 tons of material, including the iconic helipad installed at 212 meters. The Burj Al Arab became Liebherr's global advertisement. Construction companies planning mega projects, the Millau Viaduct in France, the Three Gorge Dam in China, Dubai's Palm Islands, started specifying Liebherr equipment in their bids. The company had transcended being just another machinery manufacturer. They were now the default choice for projects that pushed engineering limits. But success in construction cranes masked struggles in mining. The 1990s saw unprecedented consolidation in mining equipment. Caterpillar acquired Bucyrus in 1997, creating a combined entity with 45% global market share. Komatsu merged with Demag's mining division. Suddenly, Liebherr faced competitors with deeper pockets and broader product lines who could offer complete mining solutions. Haul trucks, excavators, drills, and support equipment as integrated packages. Liebherr's response was characteristically bold. Build the biggest mining excavator ever conceived. The R9800, introduced in 1998, was an 800-ton hydraulic excavator with a 42 cubic meter bucket, large enough to hold 2 city buses. Its 6 Cummins diesel engines generated a combined 4,000 horsepower, and the hydraulic system operated at 350 bar pressure, enabling bucket forces exceeding 2,000 kilonewtons. The R9800 targeted ultra-class mines in Australia, Canada, and South America, where scale determined profitability. At LKAB's Kiruna mine, one R9800 replaced 3 smaller excavators, cutting operating costs by 30%. The machine could load a 400-ton haul truck in 3 passes, maintaining a loading cycle of under 4 minutes. Over a 20-hour shift, a single R9800 moved 35,000 tons of material, the equivalent of 300 loaded semi-trucks. Critics called it overkill. Mining consultants argued that such massive machines created single points of failure. If one 9800 broke down, an entire mine's production halted. Liebherr countered with modular design philosophy. Every major component, engines, pumps, hydraulic cylinders, could be replaced without disassembling the entire machine. The R9800 featured onboard diagnostics that predicted component failures weeks before they occurred, allowing scheduled maintenance during shift changes rather than emergency breakdowns. By 2004, Liebherr operated the world's largest mobile crane factory in Ehingen, Germany, producing machines like the LTM 11200-9.1, a 1,200-ton capacity crane with a 100-meter telescopic boom. Its 9-axle carrier could drive on public roads, yet deploy at job sites in under 3 hours. Wind turbine manufacturers became major customers, using these cranes to install nacelles and blades at heights exceeding 140 meters. The 2008 financial crisis barely touched Liebherr. While competitors like Grove and Terex saw sales collapse by 40%, Liebherr's diversification cushioned the blow. Construction equipment sales dropped, but mining demand remained strong as commodity prices stayed high. The company's private ownership meant no shareholder pressure for layoffs or fire sales. By 2010, Liebherr employed 34,000 people across 120 companies in 50 countries, generating revenues exceeding 7.7 billion euros. Hans Liebherr's self-climbing crane had evolved into an empire building the modern world's infrastructure, one impossible project at a time. In 2010, a Liebherr LR 13,000 crawler crane arrived at a construction site in Flamanville, France, tasked with an installation that would test the limits of heavy lifting. The job: place a 450-ton steel containment dome onto a nuclear reactor vessel with tolerances measured in millimeters. One miscalculation, one gust of wind, one hydraulic failure, and the consequences would be catastrophic. potentially billions in damage and years of delays. The LR-13,000 featured a lattice boom stretching 248 meters when fully extended, longer than 2 football fields, and could lift 3,000 tons in specific configurations. But raw power meant nothing without precision. Liebherr's engineers had developed a computer-controlled winch system with anti-sway technology that used accelerometers to detect load movement, then made microsecond adjustments to cable tension, counteracting pendulum effects even in 30 kilometers per hour winds. The Flamanville lift took 6 hours. The dome was positioned within 3 millimeters of specification. Nuclear engineers who'd watched nervously from a distance admitted they'd never seen such control on a lift of that magnitude. It wasn't just placed, one recalled. It was threaded like a needle into position. This became Liebherr's new normal. Projects where failure wasn't an option. In 2014, their crawler cranes installed the spire on One World Trade Center in New York, a symbolically crucial lift requiring flawless execution. In 2018, a fleet of Liebherr tower cranes worked simultaneously on London's Crossrail project, coordinating via computer networks to avoid collision in one of the world's most congested construction zones. But the industry was changing in ways Hans Liebherr never anticipated. Automation, electric power, and connectivity were transforming construction equipment from mechanical tools into networked platforms. Competitors like Caterpillar invested billions in autonomous mining trucks and AI-powered excavators. The question wasn't whether Liebherr would adapt, but whether a family-owned company could match the R&D spending of publicly traded giants. Liebherr's answer emerged in their mining division. The 2019 R9600 excavator, successor to the R9800, featured Liebherr Mining's autonomous assist system. The excavator didn't drive itself, but AI algorithms optimized bucket fill patterns, analyzing material density in real time, and adjusting dig angles to maximize payload without overloading. Operators reported 12% productivity increases, simply by letting the machine suggest optimal approach angles. More radically, Liebherr developed an electric drive version powered by trolley lines, eliminating diesel engines entirely in mines with electrical infrastructure. At Boliden's Aitik copper mine in Sweden, electric R9600 SS operated with 60% lower energy costs than diesel equivalents while eliminating 8,000 tons of annual CO2 emissions per machine. The mobile crane division pursued similar innovation. The 2021 LTM 1650-8.1 featured Vario ballast, a system that adjusted counterweight configuration automatically based on load charts, reducing setup time from 90 minutes to 35 minutes. But Liebherr went further, integrating cranes into digital ecosystems. The Licon 3 control system now shared data with project management software, allowing contractors to monitor crane utilization, predict maintenance needs, and optimize job scheduling across entire fleets. Today, you can see Liebherr's legacy everywhere, though you might not notice it. The cranes building urban skylines carry Liebherr badges. The excavators reshaping coastlines for climate-resilient infrastructure run Liebherr hydraulics. The mining equipment extracting materials for electric vehicle batteries came from factories Hans Liebherr's descendants still control. The most remarkable part? Walk into mines in Australia or South Africa, and you'll find original R991 excavators from 1970 still working. Rebuilt, upgraded, but fundamentally the same machines. Some have moved over 100 million tons of material across 5 decades. Hans Liebherr's 1949 bet on a self-climbing crane created more than a company. It created a philosophy. Build machines that do impossible things, then make them reliable enough to do those things every day for generations. That welding torch in Kirchdorf built the world. And those red and yellow machines are still building it. In a lithium mine in Chile's Atacama Desert today, a Liebherr R9800 excavator operates in conditions that would have seemed like science fiction to Hans Liebherr. The machine works at 4,000 meters elevation, where oxygen levels make conventional diesel engines gasp for power. Temperatures swing from -15 degrees Celsius at night to 35 degrees Celsius by noon. Dust storms reduce visibility to zero within minutes. Yet the excavator runs 22 hours daily, stopping only for shift changes and refueling. This isn't remarkable because the machine survives these conditions. It's remarkable because it thrives in them, while being monitored by engineers 12,000 kilometers away in Colmar, France. Sensors throughout the excavator transmit data every second: hydraulic pressures, engine temperatures, bucket wear patterns, even the mineral composition of material being loaded. When a hydraulic pump bearing showed early wear signatures last month, Liebherr's predictive maintenance system flagged it 3 weeks before failure would have occurred. A replacement arrived from inventory in Peru, and mechanics swapped it during a scheduled maintenance window. Zero unplanned downtime. This represents the evolution Hans Liebherr could never have imagined. Machines that diagnose themselves, communicate with supply chains, and optimize performance through artificial intelligence. Yet, the core philosophy remains unchanged. Build equipment that works when failure isn't acceptable, then make it better. The challenges ahead dwarf anything Liebherr faced in 1949. Climate change demands construction equipment with zero emissions, but electric excavators and cranes require power infrastructure most job sites lack. Autonomous operation promises safety improvements, but regulators and unions resist machines that eliminate operator jobs. And the entire mining industry faces an existential question. How do you extract materials needed for green technology without the environmental destruction mining historically caused? Liebherr's response mirrors Hans's original approach. Engineer solutions others consider impossible. Their hydrogen fuel cell excavator prototype, tested in 2024, runs on hydrogen produced from renewable energy. Emitting only water vapor, the R9XXH2 delivers the same 4,000 horsepower as diesel models, but with 95% lower carbon emissions. Skeptics note, hydrogen infrastructure doesn't exist at most mine sites, but Liebherr is partnering with mining companies to build it, the same way Hans convinced contractors to trust tower cranes before supporting industries existed. In construction, Liebherr's newest tower cranes feature AI-assisted load management that prevents multiple cranes from colliding on dense urban sites. The system creates virtual no-go zones, automatically stopping jibs before they intersect. On Dubai's Creek Tower project, destined to exceed 1,300 meters when complete, 8 Liebherr tower cranes work in a choreographed ballet controlled by algorithms that would have seemed like magic in 1950. But perhaps the most profound legacy isn't technological. In 2023, a German technical school received an unusual donation: Hans Liebherr's original 1950 prototype tower crane, discovered in a Kirchdorf warehouse where it had sat forgotten for decades. Restoration revealed the simplicity of his initial design: welded steel, basic hydraulics, manual controls. Students marveled that something so primitive launched an industry. Yet standing beside it, engineers recognized something deeper. Every tower crane since 1950 uses the same fundamental principle Hans invented: a machine that lifts itself. The hydraulics are more sophisticated now, the materials stronger, the controls computerized, but the core insight remains valid 75 years later. How many technologies can claim that? Next time you see a construction crane against the skyline, or read about rare earth mining for smartphones, remember the mason from Kirchdorf who believed machines could climb. His cranes built the airports you fly through, the bridges you cross, the buildings you work in. They extracted the copper in your walls and the lithium in your devices. Hans Liebherr didn't just build cranes. He built the infrastructure of modern civilization, one impossible lift at a time. And in mines, on job sites, at mega projects across 6 continents, those distinctive red and yellow machines are still doing exactly that. Now, we want to hear your part in this story. Ever operated a Liebherr crane or watched one tackle an impossible job? Share your experience below. Each story adds another lift to this legacy, just like those iconic machines still building our future today.